Okay, so the first kind of prescribed proof, the ones we were doing before, you all have to be able to do, but they're not very formal, they're not very rigorous, because you're just using your tables for it. But it's a bit more to these, a few diagrams involved. So this is the first of the quite heavy trig proofs. You do need to learn it, and it's the proving of the sine rule. So prove that a over sine a equals b over sine b equals c over sine c. Now, how do I prove this? I'm going to have to draw two diagrams. One where all the angles are acute and one where one of the angles is obtuse. So the proof, this is everything now. From here on you need to be able to write, and you'd write it exactly like this. So proof, consider an acute angle triangle and an obtuse angle triangle separately. Okay, so we're going to draw both of those. Right, an obtuse angle triangle, an acute angle triangle, any triangle like that. Don't take that to be isosceles. And then a obtuse angle triangle. Okay, now I'm going to name all my sides in there. So I'm going to name my angles A, B, C. And they are uppercase and then lowercase. I'm going to do the same thing over here. A, B, and C, and B, A, and C. Okay, now I'm going to start my proof. But before I start my proof, now I've got to, inside in this triangle, create two right angle triangles. Please do not take this to be an isosceles triangle. It could be, but not necessarily. So this vertical line is not necessarily bisecting C. Okay, so let's do our first triangle. Proof. So let's look at this first right angle triangle here. We've got the sine of the angle A. So according to SOHCAHTOA, sine is opposite over hypotenuse. So opposite is this red line, we call that red line H. Sine is opposite H over hypotenuse, which in this case is opposite to 90 degrees, it's B. Therefore, H is equal to, B is dividing, comes across to multiply, B sine A. Now let's do the exact same thing over here. The sine of the angle B, opposite over hypotenuse, so the opposite is obviously H again. And this time the hypotenuse of this triangle is A. Therefore, H is equal to A sine B. So if both of those things are equal to H, then they must be equal to each other. So therefore, A sine B must be equal to B sine A. And let's just make that look a little like what we're trying to prove. A over sine A equals B over sine B. So so this sine is multiplying, so when it comes over it divides, and this sine is multiplying, so when it comes over it divides. So A over sine A, sorry I put my little hence there, A over sine A equals B, apologies, that's supposed to say sine B, B over sine B. Okay, now we move on to other triangle. We do something very, very similar, except we create a right angle triangle. It has to be created on the outside here, because creating it on the inside is quite difficult. We can bring a vertical line up from B, but this is easier just to do it on the outside. So I've got a right angle triangle here, and we call this H again. Now keep in mind what we have here. We have two right angle triangles. We have a big giant right angle triangle, okay, and we have the small right angle triangle. So let's start off the same way we did the last time. Proof. So we're looking at our big giant triangle now. So we're looking at angle A. So sine of A. Now what's opposite sine of A? It's H. And what's the hypotenuse of the giant triangle? B. Okay, therefore B again is, H, apologies, H is equal to B sine A. Now, let's go after sine B. Sine B. So that's our little triangle here. But, sorry, we can't find, sine B. It's not part of a right angle triangle. So we're going to have to make an adjustment here. So if this is B, inside here, I've got 180 minus B, because they make up, of course, a straight line. So instead of finding sine of B, I'm going to find sine of 180 minus B. So again, that's the small triangle. It's opposite over hypotenuse, so the opposite is H. And the hypotenuse in that case is A, so it's equal to H over A. Therefore, H in this case is equal to A sine 180 minus B. Now, this is the thing, 180 minus B. Sine of 180 minus B, we have to adjust that now, which I'm sure you'll all love. So that's a sine A minus sine B, which is up here on page 14. So it's sine A cos B cos A sine B. So it's sine 180 cos B, sine 180 cos B, and then we've got minus cos A sine B, so minus cos 180 sine B. Okay, now a quick look at our sine and cos of 180. We can see that cos of 180 is minus 1, sine of 180 is 0. So because sine of 180 is 0, this all goes to 0. Oopsie daisy. Oh, sine 180 minus B equals, so this all turns to 0, gone. And I'm left with minus cos 180, which is minus 1. So it's minus 1 times, it's minus 1 sine B, and therefore, sine 180 minus B is just equal to sine B. Okay, how does that help us out? So I have sine 180 minus B here, but I saw I can actually just refer to that as sine B. So hence H is equal to sine B. So all I've done there is I've turned this into that using these steps here. Okay, so I've got what I have up here. I've got this here, and now so they must be equal to each other because they're both equal to H. So therefore, A sine B is equal to B sine A. And when we rearrange it, this is multiplying A, this is multiplying B, so when they swap sides, they'll be dividing. So A over sine A, sorry, I'll do little hints there, little hints here. A over sine A equals B over sine B. Okay, so now we can see in both of them that we can prove that A over sine A equals B over sine B. And to be honest, they let you away with murder now in this case. So to finish that off, all you have to say actually is, in both cases, A over sine A equals B over sine B. And all you need to say is, similarly, it can be shown, they don't make you do it all over again, it can be shown that A over sine A equals C over sine C. So basically all we're saying is we could show that by just doing the same thing again, except using C this time. So if A over sine A equals B over sine B, but also A over sine A equals C over sine B, then B over sine, oh my goodness me, sine B, then B over sine B equals C over sine C. So it's a heavy proof, you just gotta practice it, but yeah, no two ways about it.